Hello, everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about a generative AI framework for credit and financial markets, and our sponsors today are Databricks and Scalata. For our presentations today, we'll hear first from Fern Halper with TDWI, and after Fern speaks, we'll be joined by Spencer Cook with Databricks, Bruno Lorenzelli, and Chris Salisbury with Scalata for presentations and a panel discussion. Before I turn over the time to our speakers, please allow me to go over a few basics. Today's webinar will be about an hour long, and at the end of their presentations, our speakers will host a question and answer period. So if at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, you can click on the Technical FAQs area and you'll receive technical assistance. And if you'd like a copy of today's presentation, you can locate the resource window to download the PDF. Lastly, we are recording today's event and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or you can share it with a colleague. Again, today we're going to be discussing a generative AI framework for credit and financial markets, and our first speaker is Fern Halper. She's the Vice President and Senior Director of TDWI Research for Advanced Analytics. Fern is well known in the analytics community, having been published hundreds of times on data mining and information technology over the past 20 years. She's also the co-author of several dummies books on cloud computing and big data. Fern focuses on advanced analytics, including predictive analytics, machine learning, AI, cognitive computing, and big data analytics approaches. She's been a partner at industry analyst firm Hurwitz & Associates and a lead data analyst for Bell Labs. She's taught at both Colgate University and Bentley University, and her PhD is from Texas A&M University. With that, please welcome Fern, and I will hand it over to you now.
Great. Thanks, Andrew, and hi, everyone, and welcome to this webinar on big data, generative AI, and agentic AI in financial services. Really happy you could make it. So I'm going to kick things off, and I'm going to talk about what we're seeing at TDWI in the way of the current state of generative and agentic AI. And since much of this depends on big and diverse data, I'll talk about that too. And I'll also talk about how generative and agentic AI can be used in financial services, and I'll give you a simple example of that. We'll also hear from Databricks and Scalata with their perspectives. And as Andrew mentioned, we'll spend a lot of our time in a panel discussion with our experts. Now, the first thing I want to point out is that the top priority for companies in 2025 is utilizing generative AI. So in our surveys, it's right behind things like self-service analytics in terms of priorities. But you can see here, it's really the top investment priority for organizations in 2025, along with AI applications. So this is a chart from a survey that we did earlier this year, where we did actually a max diff analysis, and we asked respondents, which of the following analytics approaches is your company most likely to and least likely to invest in? And you could see that generative AI beats out many of the other approaches, including machine learning, approaches, as well as augmented analytics. And even here, if you look down the list, agentic AI is somewhat lower on the list, but it's really starting to pick up steam. So the point here is that generative AI is a huge investment area. And as I said, what we also see is that agentic AI is becoming more and more popular as well as generative AI. Now, most of you on the webinar, I'm sure, are familiar with generative AI. For those of you who aren't familiar with agentic, that refers to AI systems that are designed to basically act autonomously and proactively towards specific goals and objectives, often without needing direct human insight. And we'll talk more about generative and agentic throughout the webinar, but let me give you a short example of agentic AI. One that's popular in explaining how this works is a travel planning agentic workflow. So if you think about travel planning, you would need to prepare an itinerary, maybe choose an airline, and you want to buy the tickets. So you could think of 3 different agents that might do that for you independently. So you trigger an agentic workflow. You say, I want to go to Northern Ireland in September. First you might get the itinerary back from one agent about all of the things to do in Northern Ireland and where you might stay. The next agent might show you the flight options. The next one might buy your tickets. So that's an example where you can start to think about, they're working autonomously and together because they're interacting. Now, of course, in these applications, we're most likely talking about using big data, so we're talking about large amounts of diverse data to fuel a lot of these applications, and companies are already collecting this kind of data. So in this chart, I'm showing results from that same TDWI survey as before. And here, the blue bar, part of the bar is collecting the data, because we're asking what kinds of data is your company collecting and analyzing. So the blue is collecting but not analyzing, and then the purple is currently analyzing, so they're also collecting. And you can see that they're collecting a lot of different kinds of data and they're analyzing a lot of different kinds of data. And that includes structured as well as unstructured data. In fact, if you look at the internal text data and the external text data, that's sort of midway down the list of items there. There are a lot of companies that are both collecting and not using it as well as analyzing it. And, I think that this kind of data, is basically the future. And so to manage this data, organizations are moving to the cloud and using data lakes and data warehouses, but more often in greater numbers, they're using the cloud data lakehouse. So this is data from multiple years across the survey that we do every year at TDWI. So you can see I have 2019, 2022, and 2025. And I think we started to ask about the lakehouse in 2023, and I'll speak to that. But you could see from this chart back in 2019 over on the left that the primary platform organizations were using was the data warehouse on premises. And you could see the other platforms also. This was also the case in 2022, but you could see that the cloud data warehouse was catching up. And likewise, then there was a big push to cloud data lakes then, so you could see that one also coming up. But if you look at the pink bars over on the right, by 2025, the cloud data warehouse had surpassed the data warehouse on premises. So, the move to cloud was there, as well as that was also the case for the data lake and its on-premises counterpart. But you could see here that over 30% of respondents were already making use of this cloud data lakehouse. And I really saw this come on like gangbusters, since 2022, 2023. It's been as high in our surveys as 40% or over 40% in some of our surveys. So why is the cloud data lakehouse so popular? Well, it's popular because unlike a data warehouse that deals primarily with structured data in predefined schema, the data lakehouse can store massive volumes of both structured and unstructured data, such as stream data, text data, video, image, audio, all of that kind of data. And then, whereas a data lake can store large amounts of, this type of data, the semi-structured and unstructured data, it really has no structure for supporting anything such as querying. The data lakehouse supports efficient querying and analysis. And additionally, whereas data lakes are not ACID compliant, which is a set of properties to ensure that database transactions are processed reliably, most data lakehouses are. And so this makes the data lakehouses becoming really popular for use cases such as AI that requires this massive amount of different kinds of data. And of course, Databricks is here today, and they'll talk more about the data lakehouse. So let's, for a minute, just consider a use case in financial services, such as credit data. And so this data is complex and multifaceted. I mean, just even think about loan origination. This consists of lots of different kinds of data. Processing loan applications for potential clients might be dealing with thousands of pages of documents, so we're getting at that big data that I was just talking about. And on the right here, I have some of the documents and data types that you might think about with loan origination. So it includes things like application information, things like social security number or date of birth, etc. Some of that is obviously sensitive. There would be information about the loan request, the type of loan, the purpose of the loan, the amount of the loan. Of course, there would be credit and risk data, such as credit scores, You would have to process income verification, such as processing W-2s and pay stubs. I think you get the idea. So there's a lot of data. It's structured and unstructured, and that might be stored in the lakehouse. So what we see is that organizations are starting to think about financial services applications that might use generative AI or agentic or even multi-agentic systems. And we'll hear more about this from Scalata. And as I mentioned, you need a platform to handle the data. As I mentioned, we'll hear from Databricks. So, if you're thinking about an agent type of framework, that might be an agent that can act on this curated and governed data because it's in the lakehouse. I bring up the governance aspect here because obviously that data has to be governed. So you might think to design an agentic system that has multiple agents. There might be one that's a document handling agent that ingests and parses and validates all of those documents. There could be a risk agent that computes risk, a decision agent that recommends the application or denies it. I think you get the idea. But just to drill into one of these agents for a second a little bit more, and this is simplified, let's say you're talking about a document ingestion agent. So the documents might be a trigger that starts the process. And you could see I have this orchestrator here, and that orchestrator is responsible for managing the workflow and selecting the appropriate tools. So in agentic parlance, a tool means something like an external function or an API or a system that an agent can use to interact beyond its own reasoning capabilities. Maybe here it's a custom parser. And also interpreting the LLM output. So the orchestrator controls the flow. It decides what to do next. It knows which APIs to call. It can retrieve the information. You see, I have the LLM there. There's specialized tools that allow agents to perform the task. As I mentioned, there's maybe memory obviously involved that allows the agent to store context and learn over time. And so you have this agent, that took the document as the input and went through its process and its its steps, and then the output might be a parsed document. So the steps might be, receive the task, the orchestrator puts the plan together, the steps are executed, and they might be recursive, so they might be repeated. And once the orchestrator decides that it's done, it provides the output. So the orchestrator is basically like a conductor, and there can be multiple orchestrators in more complex applications. An agent can have its own task, but it can be working with other agents, as I described before. So I'm not going to go too deeply into this. I'm sure we'll talk about it more as we move through the panel discussion. So that's a brief introduction to what's happening with big data, agents, agentic workflow, sort of all of that. And we're going to talk more about this with our panel. So let's get into that and get into hearing from both Databricks and Scalata. So Andrew, let me turn it back over to you to introduce our speakers.
Terrific. Thank you so much, Fern. And it is now my pleasure to introduce our first guest speaker today, Spencer Cook with Databricks. Spencer is the lead solutions architect with Databricks with experience delivering end-to-end analytics solutions in the cloud to iconic brands. Since 2021, Spencer has been a financial services solution architect focused on revolutionizing the industry with Lakehouse architecture. With that, please welcome Spencer, and I will hand it over to you now.
Thanks a bunch, Andrew. Always great to be here and join a TDWI panel. So as Fern was talking about, there's this whole concept that's emerged in the industry with AI, specifically generative, agentic, all these different terms. Really where Databricks has been focused for over a decade now is on the platforms that make it so that you can get that type of intelligence. Think about an agent as kind of being the tip of the iceberg. Databricks can provide, everything that you need under the surface to make that all work. So we focus on the data intelligence platform, and I wanted to talk about the data intelligence platform for financial services in particular today. And that's really become this rich ecosystem across our different clients and partners, like Scalata being a great example, and data listings on the marketplace that form this really robust ecosystem for financial services. If you think about it, like your iPhone would be a really awesome, nice looking device, but it's the apps, the access to the internet, all those different connectors that make it a great, platform. And that's the same when you look at the data intelligence platform. What we've seen in the industry is that our clients are no longer interested in just data for data's sake and AI and all this infrastructure. They're really looking at strategic objectives and how to drive organizational change. And there's a lot of areas they're focused on. You see a couple examples here on the slide. Now, what that means when you peel it back is that you need to do a couple of different use cases across a diverse set of requirements. So digital banking and personalization on the surface seems like it would be a very different requirement and choice of architecture than pricing and underwriting or claims automation. But what we've seen is that those are all shaped by data and AI. And so a lot of these projects get stuck at that data warehousing phase where they're looking in the past at what happened. To be able to take on these new use cases like segmentation, claims automation, portfolio optimization, you need to move up the data maturity curve. And that requires having access to clean data and all these different tools we've talked about. And it really is what increases your competitive advantage and gets you out of doing just infrastructure for infrastructure's sake. So Fern alluded to the Databricks Lakehouse several times. Really, this has become a industry trend where we've seen over 74% of enterprises adopting a lakehouse. Now, obviously, Databricks is both the inventor of the lakehouse, and firms like Forrester have given us, kudos for having the best implementation. But even Databricks recognized that something was missing from the Lakehouse platform. And it was this data intelligence engine piece. And that's where we can use frontier models along with your private data, the metadata like lineage and things that are only available within your data platform. Combine those together to enrich all the different APIs and engines that data teams need to deliver both data and AI use cases. And that's really what created the data intelligence platform as we know it today. It's still built on a completely open foundation, which is really critical. So all of these different connectors and all the different parts of the ecosystem, they rely on Databricks having, an open door for access and making it easy to get data in and out with transparent semantics. One of the most exciting introductions to the platform in the last year or so is this iceberg support and hoodie support that you'll see down in the bottom right. So regardless of how you've chosen to store data in your data lake, what format, what technologies you've been dependent on to this point, you can leverage Databricks as catalog to do those critical data governance pieces that Fern mentioned. And you can also do all the latest and greatest agentic capabilities that you might need as well. So when we talk about open, it can often be unclear kind of what that means, especially from a financial services standpoint, right? I don't necessarily want my banking data open to everyone. What we really mean is having an open source foundation so that everyone can innovate in the same direction. So think about things like HTTP standardizing how computers communicate over the internet. This is the same way. So Databricks has defined certain open standards for formats like Delta, that then companies like Goldman Sachs have been able to take and turn into connectors for their internal systems like Legend. So now all the users of Legend are able to take advantage of this universal standard that they've adopted, because behind the scenes, it's built on top of this industry standard that Databricks invented with Delta Lake. And so you see lots of examples of that throughout the Databricks marketplace, things like Guidewire, things like Scalata. They all work on top of this open foundation. And you'll hear about a bunch about the details on Scalata from our partners, Chris and Bruno. So when we look at openness, there's kind of two different ways of thinking about it. Obviously, you can have open APIs, open engines, things like JDBC are fairly open. What we've really innovated on is this concept of an open data lake in supporting advanced sharing techniques. And so you see an example here of Delta sharing. We have a lot of great partners like MasterCard, NASDAQ, S&P Global, building innovations on top of that. And it's really created this ecosystem of alternative data that you can bring in to power your agents, power your Gen AI, et cetera. And so it's this combination of the data lakehouse with its open standard sharing techniques, et cetera, along with these new generative AI techniques that we've combined together to create this robust data intelligence platform. And so you go from lakehouse to this complete ecosystem of bringing in new productive techniques with Gen AI on the intelligence engine, increasing compliance and lowering the total cost of ownership with the insights of the engine, and then using that momentum to create new revenue opportunities and deliver new AI products. So that's really the promise of the data intelligence platform. And you'll see a great example of some of the additional new capabilities you can get on top of that platform with these capabilities through a tool like Scalata. Just as some examples, you can see here what the AI augmented workspace looks like with our AI assistant in the side panel on the right. You can see an example of what a model risk management deliverable might look like. This is, a PDF that's being generated by a model hosted on Databricks. And so you can move your compliance into Databricks and lower the total cost of ownership while increasing accuracy. And then you can use the Databricks AI stack to fine-tune models, to do RAG, to do LLM evaluation, even to integrate third-party models like OpenAI. You can do it all through the Databricks AI stack. And all these different use cases require somewhat different strategies, different parts of the ecosystem. So that's why it's so critical that they're all part of one platform, share a common governance stack, share a common data format, because essentially, as you evolve from prompt engineering to fine-tuning, you don't have to change platforms. You can keep your momentum and keep your value chain high. So you can use tools like model evaluation, retrieval augmented generation, model fine-tuning, all to accelerate a journey towards these AI solutions. And so you're going from bootstrapping on top of your existing solution to integrating it tightly into the existing systems you have to deliver data to your internal users, to provision access to private information and private systems. And then with a combination of those controls and the connection to your enterprise data, that's how you can really see this activation cycle where you start to get value from AI and are putting things in the hands of your end users. And so we're going to hear from the Scalata team how you can deliver these things to your end users and what some of the really cutting edge UIs and experiences you can deliver on Databricks look like. But this whole idea is accelerating that generative AI journey. And so with that, I'll hand it back to Andrew. Really appreciate the time and look forward to our panel discussion. Thank you.
Thanks so much, Spencer. That was fantastic. And yes, now it's time for me to introduce our next guest speaker, Bruno Lorenzelli with Scalata. Bruno is the CEO and founder of Scalata and has over 25 years of experience in the market and 20 years in financial services industry. After founding two startups, Novastar Capital and Tax Change, he joined Microsoft AI Lab to build a new generation fintech credit architecture in 2022. And after 2 years, he built Exchange Robotics in New York and launched Scalata.ai. With that, please welcome Bruno, and I will hand it over to you.
Thank you, Andrew, and thank you, Spencer, for the intro. So Scalata basically has been built. We are part of the Databricks build-on program on top of obviously Databricks, but that actually didn't come as you mentioned, as an easy solution, because back in 22 we couldn't find clouds and environments able to support our use case, and our use case was basically answering to dealing with large data. Okay, because the financial services, I am obviously a practitioner. I've been working in finance for 30 years, and I work for major banks, and so I built systems for those banks, and I had to deal with large amount of data. And what I found very complex was to execute natural language processes, and my vision when I actually built, back in 22, the initial use case was actually to deal with actually gigabytes of data, and obviously to have a control environment. We couldn't find any cloud, we were just at the beginning. In fact, all of these new data intelligence and lakehouse, they are, they've been coming to the market over the last 2 years. Okay, so we found the answer in Databricks after kind of wandering around and using so many products from the various cloud providers. Okay, so Scalata is a framework. Scalata is a framework that deals with two fundamental building blocks. Deal with large amount of data in a controlled way. Okay, in a controlled way, meaning that data governance and obviously not abusing your legacy. And two, being able to provide a scalable vision. In other words, we know Gen AI is for us Internet 2.0, and so being able to provide a cheap and scalable solution where you can plug and play new models, new data inputs, new applications without spending millions of dollars, which is the biggest problem I say in adopting generative AI and adopting technology in general, and making democratic more or less. And we did this by obviously then creating concepts such as accelerating workflows and building any type of financial use case. The current situation we experience today, we have customers, is still this. Okay, despite implementing large solutions, people in finance, they still send emails, they create attachments, Excel, CSVs, PDF. They, even if they have automated platform, they like working on single document and send you an email. Okay, and when you implement Gen AI, although Gen AI is very popular today with all these chatbots, they still there is a suspicious around that. It's not integrated in full scale workflows, particularly in financial institutions. Okay, they kind of are playing with it. They're very curious. There are large projects implemented. So Scalata is the answer to that. Okay, so fundamentally we address three main building blocks. Okay, first one, I am going to deal with my legacy system. Okay, and I'm going to build an application, and that's why we built what's called a data marketplace on top of the Databricks marketplace, Databricks Delta tables. Okay, and that was easy for us. Okay, and so we plug and play APIs in seconds with zero cost. We plug and play models. Okay, we build the codes, technology on top of it that can handle with multimodal, because obviously this product of Scalata is to transform a complex solution that you need to code and implement within Databricks, your logic, into something that you just click and plug and play. Okay, that's what we offer. And clearly we do that by not just offering few models. It's fundamentally an offer that will fundamentally adopt the new emerging models, all the models. Okay, two, by doing that, we have our patented technology where we generate UI, and our agentic framework is fundamentally also not just a backend agentic framework. We'll go into details. We actually have a patent on our widgets. The widgets in itself, which is fundamentally could be a table, could be an Excel, digital Excel we build as an agent handling this. And it's our unique technology that we build. And finally, we're also a CRM tool. We execute workflows. We have a unique tech that execute fundamentally workflow management. And so we empower teams to collaborate on the same, obviously, on the same, let's say, Excel or on the same document management, on the same chat, in a controlled fashion. And so we execute things like compliance, security, data governance by executing all of these, concepts. So we implemented, what you say, in a holistic view, a framework that, complies with unstructured data, complies with the backend and the legacy system of banks, but also transition them into the future. Specifically, we respond to use cases like liquidity management. Okay, I can fundamentally digest, gigabytes of tables, and I can use my, obviously, pool of data via my APIs, and I can create fundamentally a risk analytic positions in seconds. Okay, and this is run on top of the Delta table technology of Databricks. Or two, I can look at new transactions. Let's say, obviously, the power of GenAI is multilingual, multi-product. Okay, so what we do, we have, implemented things such as, data mapping in seconds. So I can fundamentally digest the data in any type of language, and I can generate, if you like, a control dashboard, according to a deal I'm executing. And, it's basically personalized, and we can do this in seconds. Scalata architecture fundamentally relies on 5 fundamentally big concepts. The first concept is data ingestion at scale. We digest any type of data. We use, obviously, the Databricks technology, and we have implemented, fundamentally the kind of gigabytes operational element around that. Okay, then we provide a unique environment, which is our data marketplace, where people manage APIs, documents. They obviously control the models, and they obviously have a control data governance environment where, according to the roles and the rules, I would say the controller, go and check what they do with GenAI within a financial institution. Is a fundamental concept. And so by doing that, we also apply what is called compliance. We do not retrain the models that you plug and play, execute what is called system prompts. We execute, the codes that we retrieve from models in-house, and everything could be hosted at the client's premises. And so basically you can plug and play any type of model, and you don't actually pass data to the model. Let's say I don't pass data to GPT-4 or to Gemini, and you don't pass, obviously, documents, nothing. It's just, a context retrieval of codes. Finally, we have our patented technology. So we reproduce, the Excel, we reproduce the charts, we reproduce the documents, the portfolio management by this specific, technology that we have, which is the widget agent, fundamentally agentic workflow. It's extremely important to look at data governance. When we built Scalata, we knew that one of the biggest, challenges that financial institutions have is to control, the control. They issue basically today you cannot send an email and attachment from a bank with, confidential information because there are alerts, and banks spend millions of dollars to implement those systems. Well, for us is kind of built in. It's free of charge. Okay, no competitor at the moment within a GenAI world orchestrated, so far as we know, in the financial industry, an environment where There are 3 level of controls, there are rules, there are permission based on the UI and the widget that you can see. And, fundamentally, because it's a very complex work. So we build the ground up like this. And so there are rules and permissions and specific UI and controls on the output of the AI that are fundamentally monitor control, and people can stop, switch on, allow people to collaborate in a CRM environment. 2, obviously, we are a massive data engineering tool. We deal with gigabytes of APIs, handling, pool of APIs or documents. We can digest, in seconds that, and we can operate our chatbots with 25, 30 attachments in 1 minute with providing a credit report, okay? And we can only do that because of Databricks, because we couldn't actually find that solution anywhere else. I have to be honest, we tried for 18 months, everything possible there. It was very complex, okay? But particularly because at the time, Databricks already migrated to GenAI, okay? Already built a data intelligence platform, whereas the other product didn't have, okay? It's quite simple. They didn't have, we had to build our own, and it's a very complex thing, Finally, we have agents, knowledge-based AI. We build an agentic framework, okay? And this agentic framework is visualized by our widgets, okay? So, and it's personalized. Obviously, within the agentic framework, we will go through the kind of the webinar discussing about anti-hallucination, feedback loop, RAG, vectorized knowledge, and so forth. Our vision is to empower financial institutions to actually adopt GenAI with affordable, democratic solution. Particularly, it's a very complex environment to this exponential, to handle this in an exponential, if you like, with this exponential production of data. We are global, okay? With our technology, we can plug and play any data around the world, okay? And also with this exponential growth of LLM foundation models, you need to deal with that. Our vision is fundamentally this. Thank you, Andrew. Thank you, Spencer.
Fantastic. Thank you so much, Bruno. And now it's time for our panel discussion. But please first allow me to introduce our final guest speaker today, Chris Salisbury with Scalata. Chris is the Director of Sales with Scalata, where he thrives on innovation and high-growth opportunities. He started his career at Mava Ventures, where he sourced and analyzed startups from across the globe. Chris went on to have a prolific institutional sales career at Fitch Solutions, which led him to joining Scalata. And I'd like to ask all of my other speakers, Fern, Spencer, Bruno, to rejoin us. And Fern, I will pass it over to you for the discussion.
Great, thanks. I'm glad everyone is back. Really interesting presentations, both of you. So my first question is about the integration, the Databricks Scalata integration. And Bruno, you talked a little bit about this, but how does Scalata integrate with Databricks, and what does the joint architecture really look like in practice? And why is this type of platform necessary?
We integrate with Databricks in several ways. We have a list, we have 3 entry points. We use the full data intelligent stack, let's call it like this, okay? So we use fundamentally what is called the data engineering piece in full. So we digest data, we digest Excel, CSVs, and so we build what is called workflows, job execution, connected to our fundamentally APIs entry point, okay? And so that is necessary for documents, PDF, Word documents, for Excel, for PowerPoint, anything you can digest, okay? But also that is true for the APIs, okay? So we build our own tech, but it goes inside Databricks, and we use for that also the delta sharing technology, okay? And that is the piece where we use delta sharing in 2 ways. First of all, obviously to digest and connect and orchestrate APIs, but also we use it as, for orchestrating our RAG technology, the agent. So we vectorize everything that we digest, we vectorize, okay? And so while you digest, it becomes also, an alphanumeric vector data, okay? And so, as I mentioned before, we vectorize not just the data, but also the codes, because when we do natural language queries towards the model, selected model, we don't send all the vectorized data, okay? It's too big. We send only few identified context level, so the higher rank context level, within the specific query. So our technology picks within a vectorized data set the most relevant, vectorized alphanumeric pieces, and clearly sends this to the model, and the model then returns the code. Finally, and this is a very complex thing, finally, so I mentioned data engineering, I mentioned obviously the entire, what is called, so then we use the SQL lakehouse, okay? Everything is in the SQL lakehouse. So we have, we were one of the initial few companies to build an SQL agent. Why? The SQL agent is more accurate, okay? The SQL agent can handle the UI much better. So we built that, and we built, fundamentally SQL that can write directly into Delta tables, okay? And so we do SQL agent, whereas everyone was focusing on Python only, okay? Finally, we used the playground. We implemented the entire multimodal, the model serving, and the entire orchestrational layer of, we're building our own model, for instance, on the model service and the playground of Databricks.
And I think you had a picture of
correct. That's correct. That's correct. You can see that fundamentally Databricks sits there. The marketplace and the data entry points where we digest data goes in. The widgets are the UI, okay, orchestrating, but it's really the core of the engine after the data ingestion that powers our UI, okay? And so obviously our agents are fundamentally run on the GitHub, but then in the backend, they talk to the Delta tables, okay? They talk to the Unity catalog. Data governance, we do Unity catalog, and therefore we do metadata, okay, there, and then we control it like this. So we basically use 100% of it.
And you're talking about our agents use, what types of agents does Scalata currently offer? And
okay,
how are
yeah, I believe you have a picture there, I think.
Yeah.
Okay, so yes, so we have fundamentally, obviously, we're building our own library, the intent detection agent, okay? The intent detection agent is the one fundamentally creating the so-called knowledge, okay? And the vectorize the RAG fundamentally, okay? And by doing that, you fundamentally, we have a tech that once a user establishes that query has a proper feedback loop, we'll talk about the feedback loop. We do not call the agent anymore. Sorry, we do not call the model anymore, because we have that kind of embedded calculating knowledge in-house, and therefore the strategy, or the orchestrator, as we call it today, the orchestrator calls an SQL agent to execute the calculation, okay? So it goes on a pure execution level. We don't need to recall the model, okay? We recall the model when there is no knowledge in-house, okay? And that knowledge, the good thing is that it's siloed, because there is data governance first. In other words, let's say we have bank A and bank B, okay? They are going to have two different, fundamentally, Delta and Unity catalogs. So they build different knowledge. So the vectorized data, which is called index search, they are not going to retrain themselves, okay? So over time, they build their own mini model, okay? Without investing money. So then we do, obviously, the research agent. Deep research is very popular at the moment. We build what is called a widget farm. We will do what is called self-coding of widgets, okay? So anybody can go in and can build their own platform, fundamentally fair. So you go in and you build your UI, because why we did that? So you want to have a company, like a fund or a bank, and they want to digest 20 documents, and they say, build me my dashboard. You know, you're going to have the credit or the widget looking at the table, the one looking at the portfolio management, the one looking at the chart, and and this is going to be different. Most of the platforms today are static, standard. Okay, that's as much as you can do. Otherwise, you need to implement a new thing. With us, with our tech, again, it is patented. You build your own. Okay, and we compile the code. We build the code on the back end of it. So if you want to add valuation button, stuff like that, we have the ability to do that.
Yeah, that makes a lot of sense. So yeah, you're not constrained. You have a framework that you can use to build all of this. And how do the agents handle decision transparency and compliance auditability? I think that's especially important to our audience here.
So fundamentally, we have a data governance tool, okay? So that is built. We have three layers here. It's called roles and rules, okay? So there is the owner of the license, which is usually CTO, Chief Information Officer within a financial institution. Then there is the so-called admin, usually the managing director, and then we have the member. So the kind of the license that goes, kind of underneath the admin, and each kind of controller, they see everything that they have executed, in terms of natural language queries, document uploaded, and obviously CRM workflows. And then we have rules, we have the permissions. So I would say an admin or an owner can enable, disable, widgets and workflows, and can obviously allocate the people you can share your workflow and obviously the widget technology. So this is how we build the data governance UI basically to do that.
And that's what that makes sense.
Yeah.
With what you're saying here.
Yes, absolutely. So we built a data governance UI, and so we are constantly working with Databricks every day to review and to upgrade our, I would say, model serving stack.
So how does Databricks Lakehouse platform support the agentic workflows across, let's say this loan origination data?
Is it for me or for Spencer? For me or for Spencer?
Spencer, do you want to come in here first, or?
Yeah, I'm happy to if you want to. Sorry, go back to the question. So essentially, all data is going to come into your data lake. It's going to originate in some sort of structured or unstructured format. For the sake of most generative applications, it hasn't mattered because they really need everything to be converted into very specific tokens, et cetera. What's really changed within the last year on agentic workflows is that you essentially have agents that are specialists in both. So you can have a structured data agent that speaks SQL and can hit your data warehouse and get very structured, consistent answers. This is great if you want to get something like a roll-up of, how much profit you've made in a certain period of time. But then you can also have an agent similarly that's doing text extraction or summarization. It's looking at your unstructured data. And maybe what it's doing is saying, hey, for your worst performing months from the structured data, I'm going to grab the unstructured calls or unstructured emails from that period and analyze, why might that be? What, led to that poor performance? Those two connections on one platform with one, governance model supporting the entire end-to-end flow. That's kind of the Databricks, point of view on supporting agentic frameworks.
And Bruno, did you have anything you wanted to add to this?
We were using it. This is exactly what we deployed. So it's perfect.
Okay, great. And it's what you were talking about, the data in the data.
This is exactly our logic on how we handle the data ingestion, fundamentally, you can see that we use AI models to build metadata, to do data normalization. Then, you can change your, when you use, obviously, when you build metadata, you have what is called the key description. We use GenAI, a connection. You can connect to Claude, or you can connect to a fundamentally, let's say, to give an example, I can digest a portfolio in Chinese, okay? A portfolio or a document in Chinese or in Portuguese. So we use GenAI to build the keys inside and to build the association of data and the trees. And for us, it takes seconds. If we build this like a job implementation on the lakehouse, it takes seconds. I mean, usually this in the past, Fern, took maybe a month to do that. We're talking about, portfolios of, I don't know, 60,000 loans. So it took literally a month to do that for a data engineer.
It's really remarkable. But what about the feedback loop? What does that look like? Can users...
I mentioned just a little bit before. Yeah. So as I mentioned, I just touched on it before, you remember. So our feedback loop technology is very accurate, okay? We fundamentally store, okay, the entire, if you like, flow of data, okay? And so if there is, like an error in a model, okay? So the feedback loop, what it does, our technology tries, has a set of attempts to try to reformulate what is called the prompt logic there. So we have written natural language prompts inside the code to understand the exception management, okay? And so we store it. We store that failing point into the delta tables. And we rebuild ourselves, the so-called, attempt to use the model and provide the kind of the answer, okay? Two, that is, fundamentally internally the code. So we have specific logic of natural language prompts that accept and understand the exceptions from a failing point of a model, okay? The models, they fail most of the time. So unless they are trained. And so particularly because the data could be bad, many things, can go wrong there. And so we have fundamentally fixes there, okay? Two, we use the user feedback, third, we have a specific, pop-up, click, specific improvements. Three, when as I mentioned to you, the output of the natural, either a table or a report, stuff like that, it's okay. We ask the user to provide, a kind of a ranking, it is good. So we're going to use then the same sequence if he's going to ask again the same question, in 2 days or in 1 day. So we store it, okay? We store it so the customer is then okay that error or that fix is not going to come back again.
Okay, yeah, I'm processing that. And so you do that, and then I know you talked about this a little bit also about the guardrails and controls. What kind of guardrails and controls exist to make sure that the agent properly?
Correct. So we have obviously the anti-hallucination strategies. So basically, we have in our code, we validate the data sources, okay? First of all, okay. We, on the front end, we ask to refresh the chat most of the time, okay? We refresh the chat because the model goes into hallucination if you keep asking the same question, okay? And so we refresh the chat. And then the chat itself is, as I mentioned, you see, is anchored to a specific delta table and Unity catalog. So we minimize the mistakes because they have a special technology to actually, fundamentally clean the data, okay? Clean the data there, okay? Then obviously we execute the RAG. It's a natural process. RAG has been there, it's been built in, each agent has its own RAG, okay? So when you deal with RAG, you deal with RAG agent level. And so we minimize obviously the fact that you have a unique one big RAG approach, okay? Instead, you contextualize the RAG there with the embeddings and obviously the vectorized information that's coming out.
Okay, so one RAG for each agent. That makes sense. So this is a good overview of the framework I think that you've given us here and some of the strategies to support governance, to build the agents, the feedback loops, all of that. So Chris, let me ask you this last question. What are some of the best practices for getting started?
Yeah, so look, my focus has really been on uncovering a lot of the pain points within the financial institutions that this might be a fit for. And so I think the best way to get started is, one, looking at your data stack, looking at your legacy systems, and figuring out how you actually perform analytics and create analysis from that data. So it's very simple to get started with Scalata. It's really, once you have your own license, as Bruno was alluding to, customizing the platform towards your needs, whether that's risk management, whether that's deep research, whether that's data mapping or engineering. And we lay out the different widgets and processes to accomplish those tasks in a very user-friendly environment. So it really is as simple as customizing the platform based on the needs of your institution and your specific use case.
Okay, thank you. Well, thank all of you. Thank you very much. This was a really interesting discussion. I do see some audience questions coming in. I think we have time for maybe one, Andrew.
Yeah, thank you all. And I think we'll squeeze two in here if we have enough time for it. We do have some questions, so thank you to the audience members that asked. This first one, Spencer, looks like it's for you, and you may have touched on this already, but perhaps you can expand. This person asks, how does Gen AI app development differ from data app development when it comes to governance and security?
Yeah, absolutely. And I want to hear from the Scalata team on this one too, I think. To me, this is kind of interesting because, like they were showing in their architecture, when you're doing a lot of things that are based off text and chatbots as your interface, they're non-deterministic. You can build an application based off test-driven development, a data app that should return the same answer consistently every time you run the same flow. So I do think that one of the things that comes to mind for me is how you can put guardrails on those answers to make something non-deterministic, behave in the way that you want, et cetera. I know from a Databricks point of view, we have a lot of customers using things like our AI guardrails, people using Databricks apps, which includes a lot of these things kind of baked in from a access and compliance point of view. So I really think that it's kind of about adhering to the security and governance paradigm of whatever application platform you're building on, whether that's generative AI or data backed. Anything to add to this from the Scalata team?
So yes, Spencer, we have, first of all, before you get to generate a widget with a chatbot, each widget has a workflow, okay? A workflow interacting with Databricks, basically. When we digest, we clean, let's say, a table, a CSV, massive CSV, or an API. We do data normalization. Then we vectorize the whole thing from documents, stuff like that. We build the delta tables. In the delta table, we make sure that we minimize all the error in terms of, underscore, exceptions, points, the things that people don't understand, okay? Or a Gen AI system can fail, or a model can fail. Then, once we have 100% accuracy at the data level, obviously we look at the speed. We can only achieve this with Databricks because, we add lots of CPUs, cores, and stuff like that. Then we generate the chatbot. With the chatbot, we are sure that whatever you put into that, okay, it's fundamentally controlled, super controlled. Two, don't think that we only are chatbots. We have a data marketplace that is the old school. It's old school stuff, APIs and stuff like that. We have the data governance, which is old school, because it's kind of you need to be, you need to look at the organization. So we interface with the Unity catalog, and then you look at you create the apartments, you create organizations, you create users, you provide permissions and stuff like that. Now, so we also look at, the important things, which is not just a chatbot, okay? Most of the applications that you see there, most of the new startups in finance, even most of that, they build a unique chat. We are a platform, we are a B2B extensive platform, whereas they build the chatbot that builds reports, okay? You don't have, they're looking now, going to data, stuff like that. But to us, the data was the starting point, the data marketplace and the data governance. This is where we started before we built the chatbots, okay? And so that's how we did it.
That's great. Yeah, that sounds right in line with best practices.
All right, fantastic. Well, unfortunately, we did run out of time there with that singular question. But again, I would like to thank all of our speakers today. We did hear from Fern Halper with TDWI, Spencer Cook with Databricks, Bruno Lorenzelli, and Chris Salisbury with Scalata. Would also like to thank again Databricks and Scalata for sponsoring today's webinar. And please remember, we did record today's webinar. We'll be emailing you a link to an archived version of the presentation. And if you'd like a copy of the presentation, please locate the resource window to download the PDF. And finally, for those unfamiliar, TDWI hosts in-person educational events. Our next one is in San Diego, taking place August 18th through the 22nd. As a valued webinar attendee, we're offering each and every one of you $100 off any event package. Please check your post-webinar communications for a unique discount code and a link to further details. And from all of us here, let me say thank you so much for attending. This does conclude today's event.